In a commercial IT environment, the fire suppression system can be as destructive to your hardware as the heat and smoke it is fighting. Facility managers face a difficult choice. Standard systems save the physical building while soaking servers, while specialized alternatives protect the data but carry immense installation and maintenance costs. We can map these options on a quadrant chart, comparing the total cost and complexity of the system against the level of protection it provides to your internal assets. Wet pipe sprinklers sit at the bottom left. They are the most affordable to install, but provide the lowest level of hardware safety. On the other end, clean gas agents occupy the top right. These systems offer maximum protection at a significant price premium. To find the right balance for your facility, we need to analyze the three primary technologies: pre-action sprinklers, water mist, and gas-based clean agents like FM200 and Novec 1230. Ultimately, your choice of suppression system reflects whether your priority is the survival of the physical structure or the data processing equipment inside it. A standard IT closet provides a good baseline for evaluating budget-conscious, water-based systems. Pre-action sprinklers utilize a dual interlock mechanism. As this schematic shows, the central water valve only opens if it receives two distinct signals, typically one from a smoke detector and one from a heat sensor. If a single sensor is triggered by mistake, the pipes stay dry. The system only releases water when both sensors confirm a fire, which prevents accidental discharges caused by mechanical damage to a sprinkler head. This is a cost-effective way to prevent accidents, but the risk remains. If a real fire triggers both interlocks, the resulting water flow will likely destroy all unsealed IT hardware. Water mist systems offer an engineered alternative that attempts to bridge the gap between cost and protection. Using high-pressure nozzles, these systems atomize water into microdroplets. This creates a dense mist that suppresses fire quickly, while using only a fraction of the water volume found in traditional sprinklers. However, the savings in water volume are offset by the cost of the infrastructure. These systems require specialized, high-pressure plumbing that is expensive to install. There is also the moisture factor. Even in a micro-droplet form, the resulting humidity carries a moderate risk of causing electrical shorts in sensitive electronics. Water-based systems protect the building's integrity and satisfy insurance requirements, but they always carry a degree of risk for the hardware. In mission-critical data centers, even a moderate risk to hardware is unacceptable. These environments require a different approach. To evaluate gas-based options, we can use this matrix. FM200 has been the legacy standard for decades. It extinguishes fires in seconds and leaves no residue, allowing servers to continue running throughout the discharge without any risk of damage. But FM200 has high global warming potential. Global regulations are now phasing it out, which means future maintenance and refills will be difficult and expensive to secure. The modern alternative is Novec 1230. It uses a fluoroketone, a liquid that vaporizes into gas upon discharge. It provides the same hardware-safe suppression as FM200, but has a global warming potential of 1, making it fully compliant with current environmental standards. The trade-off is the price. Novec 1230 is significantly more expensive to install and recharge than previous generations of chemicals. Regardless of the chemical you choose, all gas systems share a single critical vulnerability: the room itself. These agents only work if the room can maintain the required concentration for at least 10 minutes. If the gas leaks out too quickly, the fire can reignite. This is why facilities must pass an annual door fan test. By measuring air pressure differentials, technicians can find microscopic leaks in the walls that would cause the system to fail. If a contractor drills a single, unsealed hole for a new cable, the room loses its integrity. The entire suppression system becomes non-compliant. Investing in gas suppression requires a permanent architectural commitment. The effectiveness of the system depends entirely on the airtight seal of the room it protects. To determine which path is right for your facility, we can follow this decision matrix based on your specific risk tolerance and budget. The first question is whether your business can survive a total hardware loss, provided your data is backed up off-site. If the hardware is expendable, pre-action sprinklers are the logical choice. They satisfy safety codes and protect the building without the extreme costs associated with gas. If you cannot afford hardware downtime, we move to the next note. Are you restricted by a building that cannot be perfectly sealed, or by a limited budget for high-pressure systems? If the room cannot pass a door fan test, water mist is the most viable compromise. It offers better hardware protection than a sprinkler, while working in a standard room environment. If your facility is mission-critical and can be hermetically sealed, gas-based suppression is the necessary investment. Finally, consider the expected lifespan of your infrastructure. If you are building for the long term, choose Novec 1230. Avoiding legacy agents like FM200 ensures your facility remains compliant with environmental laws for the next decade. These technical choices reflect a broader strategy for disaster recovery. Your suppression system determines how long your business stays offline after an incident. Align your infrastructure with the downtime you can actually survive.